So they gave us 2 raised to power x is equals to 16. So let's solve. This is 2 raised to power x is equals to 16. And we know that this is something like saying 2 raised to power x. 2 raised to power 4 is equals to 16. So, and there's a law, the ninth law, base law says that when the bases are the same, the powers are equal. So x is equals to 4. Very simple. So let's move to B part. 4 raised to power x is equals to 0.0625. And we know that this is the sentence saying 1, 0, 0, 0, 0. So 625 over 10,000 is equals to 4 raised to power x. We need to ask ourselves, is there any way we can make everything here reducible to this base? Still remember that this is the sentence saying 2 raised to power 2x, just for in case. So is there any way we can even reduce 625 and 10 to base 2? So that's what we need to check. So there's nothing common amongst them, because 625 raised to power 5 raised to power 4 will give me 625, and 10 raised to power 4. So nothing really common. Nothing. This is 5 raised to power 4, 10 raised to power 4. So 5 raised to power 4, 10 raised to power 4. So you can see clearly that there is nothing common to these two. There's nothing common between these two. So let's move to the next one. 2 raised to power x equals to 256. 2 raised to power x equals to 256 raised to power 2 raised to power 8 should give me 256. Let's be sure. 2 times 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 2 should give me 2. So 2 raised to power 8 is equal to 256. So since the bases are the same, x is equal to 8. Very simple. And let's move to number D. This should be D. So let's move to D. D says if cube root of 4 raised to power 2y is equals to 8, find y. So if cube root, we know that cube root is the sentence saying 4 2y all raised to power 1 over 3 equals to 8 is the sentence saying 2 raised to power 3. So distributive power law, we have this to be the sentence saying 2 raised to power 2y first of all multiplied by 1 over 3 is equals to 2 raised to power 3. 2 raised to power 2 is 4, then 2y. So if we don't want to do it this way, we can still say let's use distributive power law so that this becomes but I want to make the base to be the same. Yes, so this becomes 2 raised to power 4y, 2 raised to power 4y all raised to power 1 over 3 equals to 2 raised to power 3. And I told you the goal of any indices, the indices question, whenever you're doing indices, the goal is how can I make the bases the same? If I can't make the bases the same, how can I make the powers the same? That's the two things you're trying to do in indices. So that's why I reduce this to, so I use power law to multiply. So let's now do distributive power law. Applying distributive power law, I now have that this is the sentence saying 2 raised to power 4y times 1 over 3 is equals to 2 raised to power 3. Power law, sorry, applying power law. Applying power law, and now that this is the sentence saying 2 raised to power 4y over 3 is equals to 2 raised to power 3. And since the bases are the same, equate the bases so that I have 4y over 3 is equals to 3. Anything standing on this one is over 1, cross multiply, so that I now have 4y is equals to 9. Now y is equals to 9 over 4. and there is nothing common here. So if 2 go here, 2 go here, 4.5. We don't want fraction, so y is equals to 9/4, and that's my answer. So let's move to the number F on section B. That's for section 2. It says 16 raised to power 1 minus 2x is equals to 1 over 8 raised to power x. Find x. So 16 raised to power 1 minus 2x is equals to 1 over 8x. Find x. So 16 is the same thing as saying 2 raised to power 4 raised to power 1 minus 2x. And 8 is the same thing as saying 2 raised to power 3 raised to power x. So this is the same thing as saying, for the sake of space, let's not confuse you. 2 raised to power 4 minus 8x is equals to, applying indices here, this is the same thing as saying 2 raised to power minus 3x. I told you that anything that is having 1 as its numerator means that it has a negative power, and anything with negative power means that it has a numerator of 1. So since the bases are the same, equate the base so that you have 4 minus 8x is equals to minus 3x. So that by the time you collect like terms, you are left with 4 is equals to minus 3x plus 8x. So this is the same thing as saying that 4 is equals to 5x. So 4 is equals to 5x. So that x will now be equals to 4 divided by 5. And that is my answer. The Bible said by the coefficient of x. So x is equals to 4 over 5. And that is it for section 2 of indical equations. Our next class will move to section C, indical equations leading to quadratic equation.